We are aware of this as we contemplate the Sun, of its immense strength and the energy that traverses the entire solar system. It is difficult to imagine anything being able to exceed our Sun, but not our own. Within a star is a cosmic wonder that produces even the most powerful solar giants. Yet, in comparison to the red supergiant, they appear insignificant. With its irregular pulsations, huge diameters, and unpredictable behavior, the supergiant defies explanation. It remains a mystery to researchers who are still examining its potential and power. As they take a look at this magnificent star in depth, they found something frightening. Join us on this journey as we traverse the Orion constellation using the James Webb Telescope and investigate how its arrival may alter our knowledge of the cosmos and its influence on the universe. If you're interested in learning more about the universe, be sure to subscribe to our channel. Enjoy this video and activate the notification bell. Despite the fact that many people ignore this, Betelgeuse can be seen in the night sky in the northern hemisphere during the winter. Simply gaze upward at the sky and keep your attention on Orion and Canis Major in order to see this brilliant star. You can easily locate it, the orange-reddish star that marks the upper left corner of the rectangular Orion constellation. Betelgeuse is one of the biggest and most prominent stars in the night sky, making it hard to miss. However, if you've paid close attention, you'll notice that the star does not stay the same. In fact, it fluctuates in brightness on occasion. This is no coincidence. Betelgeuse, as the star is known, is not your typical star. Despite appearing to be only a small part of the vast constellation, it is actually over 640 light-years away from us. This number may not appear impressive at first, but in reality, it's a significant distance. To show how far this really is, let's say we were able to travel at the speed of light, which, regrettably, is impossible. It would still take us over 640 years to reach Betelgeuse. If we wanted to go on a trip like that with even our most advanced spacecraft technologies, it would require more than 12 million years. That far outpaces all of human civilization. But Betelgeuse's dimness isn't only due to distance. It is referred to as a red supergiant that is pulsating, meaning it's a massive, ancient star that undergoes regular expansion and contraction. Its brightness can change during these cycles, appearing more or less intense in the night sky. These brightness changes can last for long periods, spanning hundreds to tens of thousands of days. Remarkably, Betelgeuse can fluctuate in brightness across a wide magnitude, ranging from close to 0.5 to nearly 0 magnitude, making it incredibly striking. These changes follow cycles, with 185 days being the shortest, while the longest remains uncertain. There are times when Betelgeuse can become faint. For example, in February 2021, it was reported to have one of the lowest magnitudes in a long time, plus 1.614. Despite being fairly bright, it certainly appeared fainter than usual. But brightness is not the only noteworthy aspect. Betelgeuse is also known for its distinctive reddish hue, which results from its cool surface temperature, approximately 3,500 Kelvin. This temperature is significantly lower than our Sun's surface temperature, which reaches around 5,500 Kelvin. This lower temperature means Betelgeuse uses much less energy per square foot. Despite being one of the largest stars in the known universe, it appears dimmer than our Sun. It's a colossal being content with a low profile, not needing to flaunt its size to command respect. But don't be fooled by its appearance. Betelgeuse is a supergiant star about 20 times more massive than our Sun. This is one of the reasons why it has been the topic of numerous studies for centuries. It was a prominent object in the night sky even in ancient times and was first referred to by the Greek astronomer Ptolemy. Its Arabic name means the armpit of Orion. However, not much could have been known about Betelgeuse at the time. Modern telescopes have made it possible for researchers to investigate this phenomenon in more detail. By examining its light, astronomers have identified several features, such as its size and temperature. The Hubble Space Telescope, for instance, has provided detailed photographs of Betelgeuse's surface, exposing intricate gas patterns and dust. These observations have enabled scientists to develop models to comprehend the behavior of such stars and predict their future development. Further evidence has been gathered using the Atacama Large Millimeter-Submillimeter Array, ALMA, a cutting-edge observatory situated in Chile. ALMA has provided high-resolution photographs of Betelgeuse's surface, revealing key details of its structure and behavior. One of ALMA's remarkable discoveries is the existence of a large plume of gas emerging from the star's surface. It's believed that Betelgeuse's pulsations caused this plume, explained by a process known as convection, in which hot gas rises and cold gas sinks. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. Thanks to Hubble, detailed images of Betelgeuse's surface have shown dark spots, known as star spots or magnetic spots. These areas on the star's surface demonstrate especially strong magnetic fields. On the cooler surface of Betelgeuse, the magnetic field prevents gas from rising from the interior, forming a cooling effect. As a result, these spots appear darker than the rest of the surface. The magnetic field of Betelgeuse is believed to be thousands of times stronger than the Sun's. This strong magnetic field traps gas on the star's surface, creating arcs or loops that indicate intense magnetic activity. These appear as star spots. It's important to note that star spots are not exclusive to Betelgeuse, they are also found on other stars, including our own Sun. However, Betelgeuse's star spots are particularly fascinating due to their enormous size. They are a lot bigger than those on our Sun and cover a much larger surface area. These massive star spots contribute to Betelgeuse's irregular brightness and have become a key focus in understanding its complex behavior. Scientists believe that Betelgeuse is nearing the end of its life cycle. As a red supergiant, it has already exhausted the hydrogen in its core and is now fusing heavier elements like helium and carbon. Eventually, it will reach a point where it can no longer sustain nuclear fusion. When that happens, the star is expected to collapse under its own gravity and explode in a supernova. This potential supernova event is one of the most anticipated phenomena in modern astronomy. If Betelgeuse does go supernova, it will shine as bright as the full moon and be visible during the daytime for weeks, possibly even months. Despite the dramatic nature of such an explosion, scientists assure us that Earth is far enough away to avoid any harm. The event would provide an unprecedented opportunity for astronomers to study the life and death of a massive star in real time. Instruments across the globe, and in orbit, are ready to observe it. The data collected from such a spectacle could offer insight into stellar evolution, the formation of neutron stars or black holes, and the chemical enrichment of galaxies. Until that day arrives, researchers continue to monitor Betelgeuse closely. Observatories like ALMA, Hubble, and the James Webb Space Telescope are gathering new data to help decode the star's cycles and predict its next moves. In early 2020, Betelgeuse experienced an unexpected and dramatic dimming event that caught global attention. Initially, there was speculation that this was a sign of an impending supernova. However, subsequent analysis revealed that the dimming was likely due to a massive cloud of dust expelled from the star, temporarily obscuring its light. This event emphasized how dynamic and unstable Betelgeuse truly is. It also demonstrated the need for continuous observation and advanced modeling. Each new discovery brings us closer to understanding one of the most mysterious and powerful stars in our galactic neighborhood. So next time you look up at the night sky and see that reddish glow in Orion's shoulder, remember, you're witnessing a cosmic giant in its twilight, a star whose life and fate are tied to some of the universe's most explosive and enlightening mysteries. Earth and up to 20% of the star's surface, that is significantly more expansive and greater in number than the Sun's, are covered in star spots. These star spots can affect the total brightness of the star, as well as cause changes as the spots enter and exit view. Valerica's brightness can be seen fluctuating because of the spots. Cooler temperatures produce less light than the surrounding gas, which contributes to the observed changes in brightness. In the case of Roche pulsations, the structure of the star also plays a role in brightness variations. As the star grows and shrinks, star spots move in and out of sight, thereby enhancing or diminishing the star's observed brightness. Surprisingly, stars' observed brightness can be greatly influenced by these processes. The problem is that Virus is not as original as one might expect. However, there are some stars like it, sharing a number of similarities. Equally intriguing is another of Virus' cosmic cousins, Antares, a red supergiant situated in the Scorpius constellation. Antares is also a variable star, meaning its brightness changes over time, similar to Virus. Antares is about 12 times more massive than the Sun, with a radius approximately 700 times greater. Multiplied by the Sun's magnitude, it is safe to affirm that Antares is not inferior in size. Now, what do you think? Consider this: if Virus already exploded, it would only take a moment before we saw its presence in our skies. Let us know in the comments section if you enjoyed the video, and please subscribe to the channel. Thank you so much for watching. One of the most pressing concerns regarding Virus is whether it is getting close to the red mark, the end of its stellar existence. Virus and other supergiants are massive stars nearing the end of their life cycles, and it is generally accepted that these stars explode violently. This cataclysmic event, a supernova, releases a staggering amount of energy, briefly outshining entire galaxies. Researchers believe V Rouge may be approaching this devastating fate. The unusual dimming that has occurred in recent years, most notably in late 2019 and early 2020, sparked worldwide interest among astronomers. V Rouge continued to dim significantly over time, leading some to believe that a supernova may be imminent. Further research, however, showed that the dimming was not caused by a supernova, but rather by a substantial cloud of dust released from the star itself. Even though it wasn't as dramatic, this finding was groundbreaking because it contributed to our understanding of how massive stars lose mass in the years preceding their death. So, if it did explode, what would that look like from Earth? V Rouge is sufficiently far away, around 640 to 700 light-years, that its explosion would not threaten Earth in any way. Even at its brightest, the blast would pose no danger to life. But it would be so bright that scientists believe it could become visible to the naked eye, even during the daytime, for several weeks, and at night, it could outshine the full moon for months. The remnants of a supernova would remain visible in our skies for decades, if not centuries. A nearby supernova like this would be a once-in-a-lifetime event, providing real-time stellar data on neutron star or black hole formation, as well as the production of heavy elements in the universe. What remains after a red supergiant like V Rouge explodes depends on the mass of its core. If the core falls below a certain threshold, it collapses into a dense neutron star, an object similar in size to a city. If it exceeds that mass threshold, it could form a warping black hole, swallowing anything in its vicinity and distorting spacetime itself. Either outcome is possible for V Rouge, as its mass is close to the tipping point. Scientists have no idea which direction it will take, so it's critical to keep an open mind. Numerous observatories worldwide, along with space-based telescopes, are keeping watch. The Hubble Space Telescope captures high-resolution images of V Rouge's surface and the dust sputtering around it. The ALMA array in Chile probes the gas layers ejected by the star. Meanwhile, the James Webb Space Telescope provides unmatched infrared detail, allowing astronomers to see through thick clouds of dust. Ground-based telescopes, like the Very Large Telescope, VLT, track changes in its spectral and motional brightness. All this data, taken together, provides a more precise picture of how the star is evolving and what might happen next. While additional red supergiants, like Mu Cephei or Antares, are also massive, V Rouge holds a special place. It is one of the closest, largest, and brightest stars of its kind in the sky, making it a fantastic laboratory for studying the physics of massive star formation. It is not only enormous, but also wildly unstable, exhibiting unusual surface and dust activity that alters its appearance. Its sheer size is mind-boggling. If placed at the center of our solar system, it would engulf everything out to Jupiter's orbit. However, despite its grandeur, in our night sky it remains a tiny, flickering ember, still mysterious, still powerful, and hidden behind the veils of cosmic dust. This veil of cosmic dust not only hides much of V Rouge's true nature but also fuels curiosity among astronomers and enthusiasts alike. Every observation, every shift in brightness, and every pulse of energy coming from this distant giant brings with it new questions and possibilities. Could we be on the brink of witnessing one of the most extraordinary celestial events in human history? The anticipation is both scientific and emotional. A supernova from a star as close and as studded as V Rouge would offer a rare opportunity to observe, in real time, the final breath of a massive star. It would give insight into the life cycle of such stars, validate decades of stellar modeling, and possibly even reveal new physics that we have yet to understand. For astronomers, this is not just about a bright light in the sky, it's about understanding the forces that shape the universe. The death of a star like V Rouge leads to the creation of heavy elements like gold, platinum, and uranium, elements essential to planets, to life, and even to the technology we use every day. It is, in many ways, a cosmic recycling event, turning destruction into new beginnings. Meanwhile, back on Earth, the public response would likely be awe and fascination. Skywatchers and photographers would gather in droves. News outlets would broadcast updates daily. For a brief moment, humanity would collectively look up and witness something truly ancient, powerful, and sublime, a reminder of our place in the universe. Yet, while we wait, V Rouge continues to mystify. Its irregular dimming, strange spectral changes, and unstable atmosphere keep scientists alert. Every data stream is parsed carefully. Every flicker could be a prelude to collapse, or just another tremor in a long stellar life. Patience is key. The future of V Rouge is uncertain, but that uncertainty is what makes it so captivating. It could explode in our lifetime, or in 100,000 years. Either way, it has already given us much to study, much to wonder about, and much to inspire. So, as we watch and wait, one thing remains clear: Betelgeuse is not just a star, it's a cosmic story unfolding before our eyes. A story of creation, of mystery, and perhaps soon, of monumental transformation.